In this video, we're going to discuss how to graph hyperbolas. Just to kind of recap what we discussed in the first video on hyperbolas, the equation is going to look something like this or like this. There's subtraction between the terms. So if the x part comes first, the branches open left and right, and the transverse axis is horizontal. If the y term comes first, then the transverse axis is vertical and the branches open up and down. In either case, a squared is under the first term because a will be a horizontal distance in the first case or a vertical distance in the second case. A is the distance from the center to a vertex. C is the distance from the center to a focus, and c squared is equal to a squared plus b squared. A and b are both found in the equation. And the other use for a and b is finding what the asymptotes are that the branches of the hyperbola are approaching. And so the asymptotes are going to be diagonals of a rectangle centered at HK, which is also the center of the hyperbola. And the dimensions of the rectangle are 2a and 2b, so a is still that distance from the center to a vertex, which makes it half the length or width of the rectangle. And then b is half of the other dimension of the rectangle. And so we'll be able to use a and b to find the slope of those lines because it'll be something like a over b or b over a, or the opposite of that in the case where it's a negative slope. And since both asymptotes pass through the center, we can use that as our point and then use point slope form to write down the equations of the asymptotes. All right, here's our first example. We have subtraction, so that's how we know it's a hyperbola and not an ellipse. Otherwise, that's really the only difference at this point. And just like we did with ellipses, if the right side is not 1, because in our equations the right side is 1, we're going to divide by whatever number is on the right side. So we're going to divide by 16 in this case. And so we have x squared over 4 minus y squared over 16 equals 1. The center is probably the first thing you want to find. The center is going to come from the numerators. We have x minus 0 and y minus 0 inside the squaring, so our center for this one is 0, 0. And since the x term comes first, we have a horizontal transverse axis. And a is going to be the square root of 4. A squared is 4, so a is 2. And then b squared is 16, and so b is 4. So the first denominator is always a squared because a is the distance from the center to the vertex, and that should be a horizontal distance in this case since it's under the x. So we'll plot our center at the origin. We're going horizontally in the x direction 2 units from the center. So 2 units to the right, 2 units to the left. And those are the vertices. Before we draw in the branches though, we know they're going to open left and right, but we also know that they're going to approach a pair of asymptotes. So let's draw in the asymptotes. This distance b is 4, so if we go up 4 units from the center and down 4 units from the center, that tells us where the top and the bottom of the rectangle are going to be. So I'm going to draw in the rectangle with dashed lines here just to show it's not part of our graph. And the width of the rectangle, we know it's going to go out to the vertex that we plotted in each direction. And so the asymptotes are going to be the diagonals of this rectangle. So it looks something like that for the one. And something like that for the other one. And then we can draw in the branches. A couple other things you might be asked to identify on the homework are the equations of the asymptotes. So we know that the slope of this one, so the one that has a positive slope, to get from the center to that corner of the rectangle, we would go up 4 and over 2. So the slope for that line is 4 over 2. And for the other one, to get from, say, this corner to the center, we would go down 4 and over 2. So that one's going to be just negative 4 over 2. And 4 over 2 is 2. So one line has a slope of 2, one line has a slope of negative 2. And they both pass through the origin, which means that's the y-intercept. The y-intercept is 0. So we have y equals 2x and y equals negative 2x for the asymptotes. So I just used slope-intercept form there since the y-intercept was easy to find. So it's m is the slope, b is the y-intercept, and the y-intercept here was 0. And then we want to draw each of the foci as well. C squared is equal to a squared plus b squared for a hyperbola. So c squared is 20, which means c is the square root of 20, which is about 4.5. And that distance is from the center to the focus. So there's 2, 3, 4 and a half is right there. 1, 2, 3, 4 and a half. And so if you're asked to write down the coordinates for each focus, we can see here we went left and right, but we didn't go up and down. So square root of 20, comma 0, and negative square root of 20, comma 0. All right, with this one, the first term is the y term, and then the x term is being subtracted. So this one's going to have a vertical transverse axis. The right side's not 1 yet, so we want to divide every term on both sides by 4. So y squared over 4 minus x squared, just x squared, but we can write it x squared over 1 just to kind of help ourselves as we're comparing this to the formula. We still have y minus 0 and x minus 0, so the center is still 0, 0. So we can plot the center. We have a vertical transverse axis, so we're going to go up and down to plot our vertices. A squared is 4, and so a is 2. So we'll have a vertex right there at 0, 2, and one at 0, negative 2. B squared is 1, which means B is 1. So when we draw in our rectangle to help us find our asymptotes, we've got the vertical direction already taken care of, and then horizontally we're going 1 unit out from the center to the left and to the right. I am going to take a moment and redraw this so that I'm scaling by a half just to give myself more space. Okay, like I said, I'm scaling by a half just to give myself more space. So I've got this point at 1, 2, and I've got this one at 1, 2 below the center. And then this will be 1 unit to the right since I'm scaling by a half. And then this will be 1 unit to the left. So the edges of the rectangle are going to be 1 unit away from the center horizontally and 2 units away from the center vertically for this one. So A and B just tell you how far am I going from the center in each direction to plot the edges of the rectangle. We're drawing the rectangle because we need to be able to draw our asymptotes accurately, and so if we draw them as the diagonals of this rectangle, so they're going to go through the center and through the corners. And then we draw the branches of the hyperbola. We have the vertices already, and they're just going to be approaching those asymptotes without touching them. All right, and if we want the equations of the asymptotes, again, they pass through the origin, so that's our y-intercept, and we go up 2 and to the right 1, so a slope of 2 for this line and a slope of -2 for the other one. And so we have y equals 2x and y equals -2x for our asymptotes again. And then we need to plot the foci. So c squared equals a squared plus b squared. So c squared is 5, and c is the square root of 5, which is about 2.2. So we're going to go about 2.2 units. So here's 2, that would be 2.5. So it's pretty close to the vertex. Both of those points have an x-coordinate of 0 because we didn't go left or right from the origin. We just went up and down square root of 5 units. So those would be our foci. All right, here the equation is good to go. We have 1 on the other side. The center is not the origin this time. The center is going to be 3, 1. So we'll plot that. I'm going to scale by a half again, just to give myself plenty of room. So 1, 2, 3, and up 1. Actually, I'm not going to do that because I think I'm going to run out of space. We'll just make it really tiny. All right, so there's 3, 1. Okay. A squared is always under the first term. A squared is 4, so A is 2. This is a horizontal distance because x is first, so we're going 2 units to the right of the center and 2 units to the left of the center to plot the vertices. So the vertices are at 1, 1 and 5, 1. B squared is 1, so B is 1. So the edges of the rectangle are going to be 1 unit above and 1 unit below the center. So the bottom edge of the rectangle is the x-axis there. And so here's one of our asymptotes. And here's the other asymptote. So we can draw in the branches. We had our vertices plotted already. Now this time, if we look at the slope, we go from the center to the corner of that rectangle, we go up 1 and over 2. So the slope of that line is 1/2. And then for the other one, if we start at this corner and go down 1 over 2, we end up at the center. So the slopes this time are plus or minus 1/2. And we're no longer going through the origin on both of those lines. Actually, neither line goes through the origin. But we're going through the center, which was 3, 1. So we can use point slope form to write down the equations of the asymptotes. Point slope form looks like this, where m is the slope and x1, y1 is a point on the line. So x1 is going to be 3, y1 is going to be 1, and m is going to be 1/2 for one of the lines and negative 1/2 for the other line. And if you need to write those in slope-intercept form, you can do that. We've practiced that before. You just distribute the slope and then add the 1 over at the end. But I'm a little tight on space, so I'm not going to do that. And then c squared is equal to a squared plus b squared. So c squared is 5. C is the square root of 5 again. So we're going just over 2 units from the center in each direction. From the center, not from the vertex. Now, the center is not the origin this time, so we have to think carefully about the coordinates for each focus. So the y coordinate of both of them is 1, right? The center has a y coordinate 1. All these points are on the line y equals 1. But we started at the center, which has an x value of 3, and we added and subtracted. We added to go to the right, and we subtracted to go to the left. So those would be the coordinates for each focus.